So this video is going to cover part of Chapter 9 of Geometry. It's going to go from 9.1 to 9.4. And by the end of this video, you should know how to calculate the area of a figure. We're going to talk about the areas of several different quadrilaterals as well as triangles. So the area of a figure is the measure of the region enclosed by the figure. And the base of a figure is any side of a rectangle or parallelogram. So if we have our rectangle, we can choose any side to be the base. So for example, I can choose that this side is going to be the base of the rectangle. And then the altitude is going to be the segment perpendicular to the base with one endpoint on the base and the other endpoint on the opposite side. So in our rectangle here, the altitude is going to be this line where it's perpendicular here and it has an endpoint there. So now we have some conjectures about area. So the rectangle area conjecture says that the area of a rectangle is given by this formula right here, A equals BH, B times H, where A is the area, B is the base, and H is the height of the rectangle. So if we have our rectangle, how we get the area is we multiply the base times the height. And then we have our parallelogram area conjecture, which says that the area of a parallelogram is also given by the same formula, A equals BH, where A is the area, B is the base, and H is the height. But for parallelograms, we can't just take one side and call it the base and another side and call it the height. We gotta actually find the height, which is going to be a line perpendicular to here and that ends here. It's going to be an altitude. So if we're given a figure like this and given some measurements, for example, if this is 13 centimeters, this is 10 centimeters, and then we have this line here, which is perpendicular, and that's 9 centimeters, and we're asked to find the area. So we know our formula is going to be A equals B times H, and then we need to decide what measure to use for the base and what measure to use for the height. So for the base, we're going to choose this 13 centimeters here because it's alongside, it's not slanted, we can see it straight on, and we have then, for the height, we're not going to choose 10 centimeters because it's a slanted line, so we can't use it as the height. We're going to use this 9 centimeters here. So then we plug in our values, and we get 13 times 9, which if we plug it in, turns out to be 117 centimeters squared. You want to remember that the units for area are always going to be units squared. Now we're going to move on to the areas of triangles. So the triangle area conjecture says that the area of a triangle is given by the formula A equals BH over 2, where A is the area, B is the length of the base, and H is the height of the triangle. So if we have our triangle here, and we decide that this is going to be the base, then we need to find the height, and then multiply those and divide it by 2. And the logic behind this is that essentially, if you just multiply base times height, then in reality, the value you're getting is the area of the corresponding parallelogram to this triangle. If you have a right triangle, you can see that's going to be a square. Then the height is going to be that value. So if you had sides like that, the area of this rectangle would be 6, but the area of this triangle is 3 because it's half of it. And that's going to be units squared. So now we're going to talk about trapezoids. So the altitude and height for a trapezoid are a little different than from rectangles and parallelograms. So if we have our trapezoid, then the altitude is going to be a perpendicular segment that goes through both of the sides, and then the height is going to be the length of that segment. So the trapezoid area conjecture says that the area of a trapezoid is given by the formula A equals H times the sum of base 1 and base 2 over 2. So A is the area, B1 and B2 are the lengths of the two bases, so this is a base and this is a base, and then H is the height of the trapezoid. So in essence what you're doing is you're taking this value here, multiplying it by the sum of this, and then dividing by 2. So the area of kites is sort of interesting. The kite area conjecture tells us that the area of a kite is given by the formula A equals P times Q over 2, in which the diagonals, so P and Q are diagonals, are multiplied and then divided by 2. So if we have a kite like this, then the diagonals, which is going to be the lines going here and here, can call one P and one Q. We're going to multiply these and divide them by 2 to get the area of the kite, which is different from our other quadrilaterals. So if we're given this figure, we can see that it's a kite because these sides are equal and congruent in a pair here and in a pair here. And then we can see that these are our two diagonals, and we're given the lengths. So this first, we're going to call this first one P, and the length of P is 20 plus 8, as we can see from our figure. We're going to call the other one Q, and the length of Q is going to be 15 plus 15. So the lengths of our diagonals are P equals 28 and Q equals 30. And then we know that our formula is going to be A equals P times Q over 2. We're going to plug in our values. That's going to be 30 times 28 over 2. And we can multiply that out, and it's going to turn out to be 420. And since we're not given units, we're just going to say unit. So the apothem is a term you don't hear very often, but it's still important. So the apothem of a regular polygon is the perpendicular segment from the center of the polygon's circumscribed circle to a side of the polygon, and it can also be the length of that segment. So for example, if we have a square and we have a circumscribed circle around that square, then that center of that circle, the perpendicular segment from here to here is going to be the apothem. And whatever length that is also the length of the apothem or the apothem. So then we have, this comes into play in this conjecture, the regular polygon area conjecture, which says that the area of a regular polygon is given by the formula A equals lowercase a times s times n over 2, where uppercase A is the area, lowercase a is the apothem, s is the length of each side, and n is the number of sides of the regular polygon. And because the length of each side times the number of sides is the perimeter, Sn equals P, so the formula can also be written as A equals 1/2 AP. So you can also just say the apothem times the perimeter over 2 is the area of a regular polygon. So we can use this formula if, for example, we're given a regular pentagon and the circle around it, if I could draw it better, and we're given that the apothem is equal to 3 centimeters and each side is 4.4 centimeters. Then we can use this formula that we're given. So A equals ASN over 2. So we have A, which is 3. So A equals 3 times, and then we have the number of sides. We can count 1, 2, 3, 4, 5. And then we have the side length, 4.4, all over 2. And this comes out to be 33 centimeters squared.